Welcome to day 10 of 365 days of RF. Today, we explore the complete architecture of satellite orbits, low Earth orbit LEO, medium Earth orbit MEO, geostationary orbit GEO, polar orbits, sun-synchronous orbits SSO, and highly elliptical orbits HEO. Orbit classification is governed by two fundamental parameters, altitude above Earth's surface and orbital inclination angle. Low Earth orbit, operating between 160 and 2000 kilometers, features rapid orbital periods of 90 to 120 minutes. Satellites travel at over 7.8 kilometers per second, powering high-resolution Earth observation and low-latency broadband constellations like Starlink and the International Space Station. Medium Earth orbit, spanning 2,000 to 35,786 kilometers, has orbital periods between 2 and 24 hours. This zone is ideal for global navigation constellations, including America's GPS at 20,200 kilometers and Europe's Galileo system. Fixed at exactly 35,786 kilometers directly above Earth's equator lies Geostationary Orbit, GEO. At this precise altitude, the satellite's 24-hour orbital period perfectly matches Earth's rotational speed, keeping the satellite permanently locked over a single ground location for broadcast television and weather monitoring. Beyond circular paths, polar and sun-synchronous orbits pass near 90 degrees inclination, maintaining consistent solar lighting for climate tracking. Finally, highly elliptical orbits, like the famous Molniya orbit, feature an egg-shaped path with a distant apogee, allowing satellites to hover over high-latitude polar regions for 80% of their orbit. In our 3D interactive space environment, observe how altitude and Kepler's laws govern all satellite orbital mechanics.